to another in the ARM What Is Program series. In each episode, we dive into a tech topic to give you insight and perspective into some of the hottest design trends today. I'm Brian Fuller, Editor-in-Chief at ARM, and today we're going to find out what is Endpoint AI. And to help us with that, I want to introduce Chris Shore, Director, Endpoint AI Ecosystem at ARM. When he's not helping us understand what is Endpoint AI, Chris is playing the piano and ringing church bells. I kid you not, but that's a whole different story. Welcome, Chris.
Welcome, Brian. We'll do the piano and the church bells another day, but I'm happy to go on about Endpoint AI.
Splendid. Let's dive right in. So, what is Endpoint AI, Chris?
Okay, very simply, the business of implementing intelligent functionality at the edge of the network. Slightly less simply, maybe taking the smarts that you usually run on big iron in the cloud and relocating them to the widgets at the sharp end, right at the edge.
Is there a difference between Edge AI and Endpoint AI, or are they two names for the same thing?
That's tricky, just for only the second question, Brian. Edge AI, Endpoint AI, they're often used interchangeably. For me, the edge is a bit of a nebulous term. It can encompass multiple devices like routers, edge servers, hubs, and kind of the functionality gets distributed across all of those devices. For my purposes, an endpoint is where the network hits the real world, where the analog meets the digital, if you like, where the rubber hits the road. So, we're talking about implementing intelligent features right next to the sensors and the actuators that kind of form the boundary between the network and the world.
So, Chris, what are the benefits to Endpoint AI?
The benefits to Endpoint AI, well, there are a ton of them. Firstly, it's intrinsically more secure. It's more private. Your data just isn't being sent to the cloud. It's being processed right in the endpoint itself. And then it saves you a lot in terms of cost of network bandwidth. And for a product designer, product user, power in turning on the radio just to transmit stuff. It's amazing how much it costs in energy just to turn on the radio compared to running your CPU and running your sensors. So your battery operated widget is going to last a lot longer between charges. That's just a couple of the highlight benefits.
So AI and ML feel like they require a lot of compute to accomplish their tasks. So how is it possible that some of this can be done on these really tiny, power efficient endpoint devices?
That's a great question. And I think it's so great it has two answers. The first is that the available compute power in microcontroller scale devices is increasing in leaps and bounds in recent years and still today. The advent of things like the Cortex-M55 microcontroller that combines real-time microcontroller behavior with the ability to handle DSP workloads, which is a very powerful combination. And then there's the Ethos U55, that's from ARM2, and that's the world's first micro NPU, and it accelerates ML networks. And that's really changed the game as a combination. And the second answer is that the software architectures and the software techniques are continually improving. The techniques we can use today to do things like quantizing networks, optimizing to smaller data types, and so on, they mean we can do a lot more with that compute power than we could only a year or so ago. Both of these things are continuing to improve at an incredible pace for the foreseeable future. That's where your compute power comes from.
So how do people generally implement Endpoint AI in terms of silicon IP?
Well, at the edge, you've always got this tricky balance, Brian. You need as much compute power as you can lay your hands on. That's the route to the smart functionality you really want. But often those devices, they've got to be physically small, they're battery powered, they've got to be capable of real-time control and real-time actuation. And the consumer always wants it cheaper. Right? So cost constraints figure a lot here. And that drives the choices that a microcontroller hardware designer is going to have to do. You're going to have to be running an RTOS. And we see leading edge customers opting for platforms based on the Cortex-M55. And they're often using that Ethos U55 as an accelerator. And the solutions for higher performance, well, they kind of drive you towards application class processors like Cortex-A55. And you're going to run something like Linux on those. But the beauty of the current software architectures we see today is the same ML frameworks scale right across that range.
So a lot of these applications you've talked about weren't possible just a few years ago. So obviously, the pace of innovation is accelerating. How do you see endpoint AI evolving in the next few years?
I think product designers are waking up, and they're going to continue to wake up just to the possibilities of what can be done with these new software hardware architectures we're talking about and that are coming onto the market right now. And that's going to transform expectations of what can be achieved. And then secondly, the next generation, because there's always another generation, right? The next generation of platforms that ARM and others are going to bring to market over the next few years, well, that's going to open up another ton of opportunities for innovative devices and innovative service models. And the pace of change right now is breathtaking. In my job, I see that every single day, but it's fantastic kind of to be connected to the ecosystem that catalyzes great product ideas and just makes them real.
Well, it's nuts for sure, but it's nuts in a really good way. Thanks as always for chatting with us, Chris. In just a few minutes, you've educated us on a really fascinating topic. Check out all our other What Is episodes here and be sure to subscribe to this channel because we'll be adding more as the year progresses. Thanks for listening.